Hi, I'm Mark Turner, the External Relations Director of SRM 360. Welcome to our third live discussion. For those who haven't joined us before, we're a relatively new NGO. We formally launched in May, and we aim to support an informed discussion around SRM, sunlight reflection methods, also known as solar geoengineering, and how these approaches might affect a variety of climate impacts. This is a controversial topic overall. For our part, we don't take a position on whether SRM should be deployed or not, but we do support its research in the context of a heating world and broad-based discussions on the best way forwards. Our goal is to present the science and the issues in forms people can use so they and their audiences can come to their own views and contribute to debate and decisions. So thank you again for coming. We have more than 120 people registered for today, and I hope you enjoy the discussion. You can ask questions in the Q&A box at the bottom of your screen, and we will direct those questions to our panelists both halfway through and at the end of the session. I'll now turn over to Pete Irvin, our editorial director. Pete, over to you.
Thanks, Mark. Let me just share screen quickly. Okay. So today our discussion focuses on wildfires, their impacts, how climate change is affecting them, and whether solar geoengineering may be able to help tackle this growing risk. Recent years have seen some really catastrophic wildfires, several of which have broken records. For example, in Australia in 2020, we saw its worst fire season on record, with an area of around 18 million hectares burning, an area around the size of Florida, or 3/4 the size of the UK, which also destroyed over 3,000 homes and the ecosystems home to an estimated 3 billion animals. In 2021, Russia saw its worst fire season in record since records began, with over 18 million hectares burned again. Again, a thick plume of ash reached up over the North Pole. 2023, we saw both Greece and Canada saw record-breaking fire events. The Greek fire declared the largest ever recorded in the EU at the time, and the Canadian wildfires burning over 18 million hectares, and leading to over 100 million North Americans seeing really serious air quality impacts, as well as very visible changes in the appearance of the sky, as some of you in the Northeast would have noticed. This year has also seen some exceptional fires, with Canada experiencing its second worst fire season on record, and with fires currently burning from one end of the Mediterranean to the other. To discuss wildfires and how solar geoengineering might affect them, I'm pleased to be joined by several leading experts on these topics. We have Dr. Patrick Brown, head of Climate Analytics at Interactive Brokers, Senior Fellow at the Breakthrough Institute, and an affiliate of the Wildfire Interdisciplinary Research Center at San Jose State University. We are also joined by Dr. Danielle Touma, Research Assistant Professor at the UT Institute for Geophysics at the University of Texas at Austin, Dr. Brian Buma, Senior Climate Scientist and Coordinator of the Climate Innovation Initiative at the Environmental Defense Fund, and Dr. Lili Xia, Co-Director of the Rutgers Impact Studies of Climate Intervention, or RISCI, lab, and a staff scientist at the Degrees Initiative. Just stop sharing there so you can see everyone. All right, Brian, you've studied fires and lived in fire-prone areas for years. What is a wildfire, as opposed to the other kinds of fires we see? And what kind of impacts have they had in your community and have more broadly? And you're muted, by the way.
Thanks. Yeah, so wildfires are fires, obviously, but they're distinct from agricultural fires. So they're fires unintentionally set or set naturally that occur in ecosystems essentially outside of direct human control. So they're not like an agricultural burn where you're trying to clear corn stubble or a field in the Sahel. So wildfires are, we'll get to this later, but they're necessary components of ecosystems. They're a thing that's happened for a long time. But in the context of humans, if we're in the way, they can be really destructive. So I have had some really personal experience. I live in Boulder, Colorado, and over the last couple of years, I've been evacuated multiple times for wildfires in the neighborhood, including one just a couple of years ago that started when a down power line ignited some grass during a 100-mile-an-hour wind event, 110-mile-an-hour wind event, so 160, 170 kilometers an hour. Quite an intense windstorm that burned down 1,000 homes in about 4 or 5 hours. So if we're in the way of wildfires, these phenomenon, it can be pretty destructive.
And beyond property damage, you say it's a natural part of ecosystems, but how is this? I guess it's damaging in some cases, and obviously the things that get burned down are lost. What's
I
your sort
think
of sense of the ecosystem
Sure.
impacts?
Actually, so fires have been around basically as long as we've had land plants. I mean, hundreds of millions of years fires have been occurring. And plants and, excuse me, organisms have evolved to deal with characteristic fire regimes, which is just the pattern of fire that typically happens in a landscape. Some landscapes around the world burn every year or two, and some burn every couple hundred years or longer in between fire events. And species really have adapted and evolved, and communities have adapted and evolved to deal with this. So in many ways, you can think of fire as a necessary component of an ecosystem, just like temperature or precipitation. It shapes what you see. But with climate change, we're shifting that balance, and now we're pushing conditions for fire to be very, very different than what they were historically. And as a result, um, coupled with the increased number of people living in burned areas and starting fires on accident or on purpose, we're seeing fire regimes which are very different, and you could call them, unnatural patterns of fire. And that's a real concern.
Yeah. And I guess in addition to these direct impacts of fire, things being burned down, there's sort of an indirect impact through the emissions that they cause. What impacts does that have on people and on our prospect of dealing with climate change?
Sure. So smoke so yes, direct impacts of fire, burning down ecosystems, which again could be good or bad depending on how frequently those fires are occurring and whether that's a natural regime or not. But fire has a lot of deleterious impacts on human communities directly. So whether that's burning down houses or inhaling smoke or just disrupting trade, it can be a really big deal. So in the 2018 fires that hit California, there's estimated about $150 billion worth of damage from those fires. Only about a quarter of that was from direct infrastructure damage. Another quarter was from health impacts, and a full 50%-ish was just from disruptions to highways get shut down, trade gets shut down, people can't go to work. And so you end up with massive disruptions to our way of life, um, and just daily operations, both because people are getting sick, it's exacerbating underlying health conditions, but also just because you can't move around the way you normally do when your air is suffused with smoke.
And how much do these? I mean, I'm presuming fires are becoming more intense or growing, covering a wider area. But how much of a contribution do fires make to CO2 emissions? Is it growing? Is it a big deal?
Sure, yeah, emissions. So fires in general, emissions are a more complicated story because, like I mentioned earlier, there's agricultural fires and there's intentional fires and then there's wildfires. And the emissions from agricultural fires have actually been declining over time due to changing agricultural practices. Wildfire emissions have been going up. So we sort of have this downward trend associated with humans on purpose anyway, and then an upward trend associated with climate change driven fires. And right now they're roughly in balance, if anything, a little bit down, but the wildfires are going up, especially in places like the Boreal, which is hitting the east coast of the United States, the smoke is. Those emissions are a feedback to the climate. So if there is more emissions going out than coming back in via regrowth, if the fire and regrowth are not in balance, you have a net flux to the atmosphere, and thus you increase climate change. So we call that a positive feedback. And our estimates are that those feedbacks, both fires and things like wetlands and permafrost thaw, and they're all kind of associated in parts of the world, are actually warming the Earth considerably and may reduce our time to hitting our climate ambitions like the Paris Accords by years. Like we may have less time than we think because of these emissions.
Oh, thanks. Patrick, what's needed for a wildfire to occur? What are the basic ingredients and how do human actions affect these factors?
Yeah, so there's a few ways to break this down, but one common way would be to say that you need the three ingredients of ignition. So you need, a spark to start the fire. You need the fire to be burning something. So you need fuel, which is typically vegetation and unfortunately sometimes structures. And then weather is a third component that really kind of dominates the behavior of the wildfire after it starts. So, going through those and like the human contribution. So natural ignition sources is dominated by lightning. So you occasionally will get, a spark from a falling boulder or a wildfire started by a volcano, but it's the vast majority are started by lightning. But in terms of fires overall, humans are causing the vast majority of fires on the surface of the planet today. So, depending on the region, it's something like 70 to oftentimes over 90% of fires are started by people. And so those are, the types of causes that you might expect. So it's, equipment use like chainsaws, lawnmowers, so sparks from vehicles, ATVs, dirt bikes, smoking. You have barbecues, campfires, fireworks are a big one. We see a big spike in the United States around 4th of July in terms of fires. Arson gets, a lot of headlines. Then Brian mentioned utility caused fires. So that's been a huge issue in California. And those fires tend to be very catastrophic because they're caused by, windstorms downing power lines. And so then you have wind, a very bad wind situation on top of the fire just being, lit in the first place. So that's the ignition side. So huge human component to the ignition side. And then the fuel component, huge human component to the fuel, or human caused changes in the fuel component as well. And fuels, really are fundamental to how the fire behaves. So we look at fuel load, how much fuel there is. A fire is going to burn very differently in grass, compared to an old growth forest, that type of thing. We look at continuity, how easily a fire can spread without encountering gaps. Fuel chemistry, how much, a eucalyptus plant with a bunch of oil in it is going to burn very differently than a different type of plant. And aridity, how much moisture is in the fuels. And so humans, radically change fuel characteristics. I mean, but it's very complicated, because you have a situation where, you might build a road through a forest, and so that would break up fuel continuity and be potentially detrimental to wildfire activity. But you're now introducing a spark source, potentially having that road there. So, one thing that I've looked at and concentrated on is the fuel buildup in the US West and in California that occurred after basically the US government implemented fire exclusion policies in the early 1900s. So the rule was the 10 a.m. rule, that all fires should be put out by 10 a.m. the next morning. And that worked pretty well for several decades. But unfortunately, what that meant is that you're just building up massive amounts of fuel in the forest. So you have situations now where forests used to have this kind of high frequency, low intensity fire regime, where every about 10 years a fire would come in and clear out brush and smaller trees. And the fire exclusion policy worked to the effect of basically allowing a century of buildup of smaller trees and brush in these forests. And one study found that we have like 4 times more trees in ponderosa pine forests in the Western United States now than we did 100 years ago. So massive changes in the amount of fuel. And so then you have a situation where kind of when you do have fire weather, which kind of the shorthand for that is hot, dry, windy, then you've set up the landscape for much more catastrophic fires that are much more difficult to control. I think Dr. Touma is going to talk more about the weather component.
Yeah, so just a reminder to people, we've got a Q&A session coming up. We're going to split this into 2 halves. And in the first half, we're going to focus more on the basics of fires and how climate affects them. And in the second half, we're going to think more about solar geoengineering, just to start thinking now about questions you might be interested in. But Danielle, can you explain in more detail the weather conditions that lead to the most intense fire spread, and how climate change is affecting these factors? And you're muted.
Yeah, sure. Thanks for setting that up, Dr. Buma and Dr. Brown. So as Dr. Brown mentioned already, you do need hot, dry, windy conditions. And to get in a little bit more detail about that, so you do need high temperatures and dry air, so low humidity, to have wildfire conditions, and these kind of act on multiple timescales. So you need to have a long period of dry, warm conditions to kind of set up those drought conditions to dry out your fuels or vegetation that will burn during a wildfire. But they're also important on kind of shorter timescales, because during a wildfire is more likely to spread and be more severe if temperatures are higher and conditions are drier. So That's one important factor, but the other really important factor is wind speed, and wind speed is especially important for grass fires, since once you have a high wind going, exactly like the Marshall fires that Brian was talking about, you can get fires to spread quite a long way really quickly if you have high wind speeds. And yeah, and it can control kind of like which direction it's going. So wind direction also matters, and how fast it spreads. And so in terms of climate change, we are pretty confident that climate change has increased temperatures across the globe and in many wildfire-prone regions. There's been a lot of evidence pointing towards that, and especially kind of maximum temperatures, which is what wildfires care about more. And we've also seen that in some regions, relative humidity has also decreased. And usually these go hand in hand. When you get higher temperatures, you also get lower humidity in terms of changes. And so we are pretty confident about those. So for example, we've seen it in Western North America, in the Amazon, in the Mediterranean. But one thing, what we're not confident about is wind speed, and it's really hard to kind of understand how climate change has influenced wind speed, because we rely on climate models a lot of times to understand the influence of climate change on certain weather variables. And unfortunately, our climate models are not the best at representing wind speeds. So that's one thing that we're still kind of unsure of in terms of how climate change has altered wind speeds when it comes to wildfire spread. And so, and this is really important because, as I said, it can really drive how a wildfire spreads. However, as the climate continues to warm, we are kind of setting the stage a lot more times in terms of providing the right conditions for a wildfire to start and to spread. So by creating warmer and drier conditions, we are, you know, giving wildfires more of a chance to spread over larger areas and kind of for longer periods of time. And another thing I wanted to mention too, it's not just the daytime temperatures and humidities that matter for wildfires, but in the past, there's a study came out recently showing that in the past we used to kind of get a break at night for wildfire spreads. So kind of temperatures used to go down enough and humidity used to rise at night. But now, but in more recent years, we've kind of stopped doing that. So basically the climate doesn't cool enough at night anymore, and relative humidity kind of stays pretty low. And so this prevents from wildfires from kind of taking a break from spreading. So we've been seeing wildfires spread throughout the night more often. While in the past, there used to be kind of a drop off in that. And so,
Sorry, when I just move on to
yeah,
Lili.
sorry. Yeah,
So Lili,
go ahead.
you've got Danielle sort of set the scene there on climate change. Is there anywhere we should expect the greatest increases in fire risk?
I mean, from previous, like Patrick and Brian and Danielle mentioned about how wildfire is like started. So I think we should really think about that. So from Patrick, what said, there needs to be ignition, there needs to be enough fuel, vegetation, and then Danielle mentioned about the fire weather. That's extremely important. So I think climate change really probably have the most significant impact on the wildfire weather. So that's the maximum temperature, precipitation, the humidity, and all those climate variables. Climate change will have, in general, most scientists agree, a hotter and drier condition in some places, hotter in most places, and like drier place getting drier. And so combining those together, so places in general, you will see increase of fire weather condition, like just Danielle mentioned. So in that way, based on like the observation, you will see for mid-latitude, like the Mediterranean or Western North American or Canadian regions, those regions from past record, most of the wildfire occurred after the extreme wildfire weather. So that's highly correlated. So in the future, you could imagine if those region has like increased wildfire weather condition, then you are expecting an intense wildfire. But for tropical region, yeah, go ahead.
I guess I'm going to jump in. CO2 is also rising, and that's boosting plant productivity. Is that helping or hurting on wildfires?
That's the point I really want to go to, because it's another important factor is bioclimatic. That's an important factor for wildfire as well. So that's a few vegetation. So if you look at a tropical region like Africa and savannas, actually the burning area reduced significantly because there's not enough fuel to support the burning. So that's one thing. And if you look at Amazon, the rainforest, you will see in general that's very humid, very wet condition, very hard to have wildfire. But like with the global warming and with a little bit constraint from like the heat stress, but also the CO2 fertilization, the vegetation really have increased. But like if but I feel like for the tropical regions, that's we need to think about another thing, that's a human activity, because over there, even it's like the very wet condition, but with the deforestation and the degradation makes those ecosystem less constant to dry conditions. So even a very mild drought condition could really increase the wildfire occurrence. And I do think like CO2, yeah, CO2 fertilization, probably that will enhance the fuel, the vegetation.
Yeah. Well, speaking of human interactions, Patrick, on our current trajectory, it looks like the world's perhaps on track for another 1 or 1.5 Celsius of global warming. And you've looked in depth at the fire risks in California in particular. How do you think that climate change, this sort of magnitude of climate change, would compare to the other human factors that will shape fire risk in California over the next several decades?
Yeah, I mean, so you frame that in terms of a global warming number. And so I think it's relevant to kind of back up and think of it this way, where, mean temperature has not been the dominant driver of fire activity historically. That's the case in California, it's the case in the US West, it's the case in the global average. And what I mean by that is that in all three of those geographic locations, California, the US West, and in the global average, we think that there was more area burned per year in a pre-industrial climate than what we have today. So I think that gives us hope that we're not just chained to global average temperature in terms of making a difference going forward. And that's the research that we've explicitly been doing at the Wildfire Interdisciplinary Research Center, where we're looking at proactively reducing fuels in California going forward, and doing that in scenarios where you are getting the warming from climate change over the rest of the century. So proactively reducing fuels means mechanical thinning and controlled burns or prescribed burns, where you're burning the land surface under conditions where you're hoping that you have full control over that fire, and so it's not escaping. And so just to put some numbers on it, what we found is that if you do that type of proactive fuel reduction on 3% of California's land surface, then that can completely negate the increase in wildfire danger that you get under a 4.5 warming scenario over the remainder of the century. And
so your 4.5 warming scenario is sort of the one I was describing, of about 3 Celsius of warming by the end of the century.
Yeah. Right? Yes. Well, not from today, but yeah, overall, right? Yeah. So I mean, it's a huge lever. And so that's one thing, that's the fuel component. But then there's efforts to reduce human ignitions, and we actually think that has been relatively successful over the past couple decades, partially due to reduction in smoking, culturally. So you have kind of incidental, changes in that. But then, there's, efforts to reduce utility-caused fires, burying distribution lines, having lines that automatically de-energize when they make contact with an object. You can disincentivize building in the wildland urban interface, which is our jargon for just kind of, more rural areas that are prone to fire danger. Because that's been a huge component of this in the US anyway, that we've seen a 50% increase in the number of buildings in the wildland urban interface just over the 30-year period from 1990 to 2020. And so that's more, human ignitions, and then it's more people in harm's way of those fires when it does happen. So there's these other levers that I think.
Patrick, I think I'm going to just jump in now. We've got a few questions from the audience.
Sure.
So let me start with one question for Brian. What are the latest developments you're aware of in using remote sensing to predict wildfires?
Yeah, there's a lot going on in the wildfire remote sensing space, probably less in predict, but more in detect from remote sensing. I'm actually fairly deeply involved with this new constellation called FireSat. So it's a separate organization called Earth Fire Alliance, which is building and launching satellites that aim to, by 2030, be able to detect and report, like send down the information, any wildfire in the world within 30 minutes by 2030. So it's going to be a constellation of fairly small satellites. There's one up there right now. There'll be 3 in about a year's time, and then they'll scale in batches of 10. And like I said, the goal is rapid detection. And what that rapid detection allows us to do is make strategic decisions. So like what Patrick was just talking about, there are people in harm's way. If you can get information on a fire start right outside LA or right outside Sao Paulo in Brazil or right outside Cape Town, you can actually get on that fire right away, especially if conditions are bad, and potentially suppress it if you're concerned about health and safety. Or you can decide, hey, this is in an okay spot, we're going to let this burn, and we're going to monitor it. It also allows us to manage the climate impact. So there are a lot of new things. There's also private companies like Aurora Tech, and Canada is going to send up a satellite called Wildfires. So there is a lot going on in the remote sensing space associated with rapid detection of fires.
Fantastic. I've got a follow-up for Patrick. And by the way, also anyone else, feel free to put your hand up or leap in if you'd also like to add to the answers of this question. And also, I'm noting a couple of questions here coming in around related to SRM, which I will do in the second half of the conversation, where we're going to focus more on SRM. Patrick, we have a question from Gary. To what extent are industrial silviculture practices and tree plantations contributing to extreme wildfire behavior?
Well, I think it depends on the time frame. So now, the policy for the U.S. Forest Service, for example, is when you're kind of you're optimizing for fire danger, where you only take out small diameter trees and you kind of recreate what the situation was in the 1800s, where you had indigenous people burning the landscape specifically for wildfire control in a lot of cases. And so that a lot of times those trees are then used for, sold for lumber, but it's not actually the optimum. It's not optimized for lumber sales. For lumber sales, you want to take out the big fire resilient trees. And so that can be very detrimental. So it very much depends on how you do the logging. When it comes to fire resilience. So a lot of the initial practices were go in and take all of the most fire resilient trees out, the old growth out, and then what's left behind is often much more flammable brush and grass that will take over. And so that can be very detrimental, but it can be done in a way that is less economically optimal from a lumber perspective, but it's better for fires. Yeah.
Thank you. And one more, if we could answer this one relatively quickly, although I'm not sure how easy that will be, but perhaps I'll put this to Lili. What role do anthropogenic aerosols play in wildfires? Do you see any role there? A recent study, according to Leon, estimates that decreases in aerosols could lead to increased boreal forest fires.
I mean, it's anthropogenic aerosols. It's definitely like aerosols in the troposphere will have the cooling effect. When we remove it, it will make the global warming faster. And like when we reduce the anthropogenic aerosol, then there will be more sunlight hit to the surface. So I would imagine that would, like for the forest, probably with more sunlight, and then the soil condition probably will be drier, like it will be more intense heating there. So I would imagine maybe that's the reason why there's even more wildfire because of the dryness over there. I didn't read that paper, but yeah, I would imagine that's probably the case. Danielle, do you have any comments on that one if you are familiar with that study?
Yeah, I'm not familiar with that study, but I've done a similar study where we looked at the role of both greenhouse gases and anthropogenic aerosols on fire weather specifically. And we did find that, yeah, as Lily was saying, that we do get warmer conditions as we, you know, as we decrease the aerosols, but it's very localized changes basically. And in some cases, that additional warming can also influence how precipitation works and relative humidity works. And so there's also knock-on influences from that warming. And we also saw that in some regions where we actually increase aerosols in the future, such as Southeast Asia, we actually see drying there because there's an influence on the monsoon region by cooling the land a little bit too much through those increased aerosols. So there are a lot of different regional effects when it comes to anthropogenic aerosols, which is not what like greenhouse gases has a more globally kind of uniform impact.
So I think that's a nice segue to the next section, Pete. Maybe I'll pass it back to you.
Well, speaking of aerosols, Danielle, you published a study a couple of years ago that looked at extreme fire weather risk under climate change and stratospheric aerosol injection, or SAI, geoengineering. What did you find?
Yeah, so unlike anthropogenic aerosols that are in the troposphere, when we inject stratospheric aerosols, and these are usually highly reflective particles, once we inject them into the stratosphere, they're quite well mixed globally. So you actually see kind of a cooling effect almost everywhere across the globe. And so we do see that when we, in these climate model simulations, so just to kind of reiterate, these are model simulations. We haven't done this in the real world. But when we look at these in these simulations, we do see kind of a reduced risk in extreme fire weather events. So these are, again, dry, warm, windy conditions that can lead to wildfires. We do see a reduced risk in many areas, for example, in the Mediterranean, in parts of the US, Canada. But in some regions, we actually see an increase in extreme fire weather events. And this is because there's this dynamical change in our climate that influences precipitation and relative humidity. And so we see in some regions, such as West Central Africa, so that's on the coast of West Central Africa, where it is a wildfire-prone region, as well as parts of the Amazon, we do see actually an increase in fire weather risk if we do go with SAI compared to if we just continue warming the world. So while there's a big benefit in terms of reducing wildfire weather or weather that can lead to wildfire, there are some regions that are still, it would be quite risky to deploy SAI. And I just want to say that, these models are global climate models. They don't resolve things very well. In some cases, for example, as I mentioned before, wind speeds aren't resolved very well. So we don't really know what's going to happen with surface wind speeds when it comes to SAI. So there's still a lot of uncertainties where we can't really tell what's going to happen with SAI.
Thanks. So Lili, you were also involved in a paper that I think used the same model, but looked at wildfires in a different way, looked at the overall area burned, the amount of emissions. Can you add to what Danielle's already covered there?
Yeah, sure. Actually, that study was led by Simon Tim's postdoc, and Simon is here. So if there's anything you want to add on, please. So that study was done by the same model, but look at the different SAI scenarios. So it's a little bit different to geoengineering scenarios, but using the same model. And it's not looking at the fire weather condition, but it's used the interactive fire model coupled in the Earth system model and directly look at the burn area and the carbon emission from the wildfire. So I think the conclusion is in general, very similar to Danielle's conclusion. So by the model simulation, with this sulfate aerosol injection, and there will be reduced burn area and carbon emission from wildfire globally. But if you look at regional, then there's some differences. So from this particular model, and you will see in boreal forest, actually the burn area increased under geoengineering. And the reason is for this specific model, actually with geoengineering, the soil moisture there is reduced. So it created a condition easier for wildfire.
Yeah, so I guess if I'm sort of summarize these studies, you looked at a global deployment of stratospheric aerosol injection, which adds these particles across the whole planet, and you produce a cooling across the whole world that reduces one of the key drivers of fire risk across the planet. But then there are shifts in rainfall that lead to some areas getting drier, and those areas that get drier under SAI could have an intensification of wildfire risk. Great.
Yes,
Cool.
and also, Peter, I want to add on another thing, the bioclimatic factor, the vegetation. With geoengineering, with the cooling and the precipitation shifts for our model study over Africa, actually for the savanna area, the burn area increased because there's more fuel to supply wildfire. Yeah.
Yeah, that we talked about earlier, the CO2 boosts the plant growth in places. Great. So Patrick, you've looked across the range of factors that shape fire dynamics and our exposure and vulnerability to them. Well, what's your reaction to these findings? How much of a role could stratospheric aerosol injection play in limiting fire risk, and how does it weigh up against these other things?
Yeah, I mean, I have no reason to doubt what the models are saying in terms of the direct influence of this on area burned. But I do think that that wildfires are not necessarily like a quintessential argument, in favor of geoengineering or in favor of aerosol injection, just because there are so many other tools in the toolbox, and especially if you're worried about downside risks of geoengineering. So just to review the tools that we're talking about, that humans have this direct effect on ignitions. They have this direct effect on the land use and choices on managing the land. They suppress fires through firefighting efforts. And then when it comes to impacts on people, we can have policies of limiting exposure in terms of where people build houses, home hardening policies, making houses less flammable, that type of thing. So there's just a lot of other dynamics at play that you can activate before going to a global scale temperature control mechanism, which maybe is more appropriate if you're talking about something like AMOC or something like that, where it's like there's not some obvious thing to do directly on the ground. And yeah, so I mean, and this perspective really is informed by being in the paying a lot of attention to the wildfire community in California and listening a lot to forest managers and to wildland firefighters. And I think it's just important to make the point that that those groups, emphasize very different things than what climate people tend to emphasize. You ask climate people about this, and it's presented as a climate problem, and I'm a climate person. You tend to get climate change related solutions, right? That's either energy policy or in this case, a geoengineering potential policy, where if you talk to forest managers or wildland firefighters, they're going to emphasize much more, where people live, fuels and prescribed fires, firefighting resources, home hardening, that type of thing.
Great. So there's a lot of options for adaptation here. Brian, do you sort of concur with that?
Yeah, I would. I think unlike many things for which SAI is targeted, like heat stress or droughts or intense heat, fire is sort of a second or third order variable. There's a lot of things that go into it, including ignitions. And when we talk about risk and exposure, that's a lot of times, like what Patrick was saying, a function of where people are living, what they've been doing to the fuels around their house for the past 50 years and things of that nature. The one thing I would add to build is there's a lot of things that management of fire that we don't understand yet. So Lili was saying the boreal forest could increase emissions even as the global average goes down. Well, when the boreal forest burns, it does, release a lot of smoke and things, but it also can increase permafrost thaw rates because you're removing insulating things. There's a lot of feedbacks. Fire is just very complicated. And so when I think about the effect of SAI on fires, I'm not sure we're there yet in terms of what this will actually do to global climate or to risk. One, because risk and it's a people problem more than an SAI problem, really, in a lot of ways. And on the climate side, it's a complicated thing, and the components aren't necessarily well modeled yet. And so understanding how the fires will filter through ecosystems and through permafrost and through emissions and through human societies, it's just hard. And so this is an important area to keep looking at for sure.
Well, yeah, not only is this tricky, it's also tricky to communicate on. I mean, I think something maybe we should just make sure everyone really understands. Like, none of this is actually happening today. People aren't deploying solar geoengineering. This isn't happening. But we have seen an apparent rise in the prominence of conspiracy theories around, weather extremes, fire weather being caused by geoengineering or cloud seeding. Danielle, what are some of the challenges of communicating about wildfires and climate's impact on them, and how much are you concerned about these conspiracies? And you're muted, by the way.
Yeah, it's good that you bring that up, because I personally haven't seen a lot or anything really about wildfire conspiracies. I mean, you hear a lot about like arson and things like that, but not so much in the climate geoengineering world in terms of wildfire. I mean, I have heard more about conspiracy theories when it comes to cloud seeding and how that can impact floods. And I know there's also some research around that, but I'm not the person to ask about that really. I think the hardest thing about communicating about wildfire is kind of what we've been talking about this whole time, how there's so many different factors that go into it and all these different uncertainties when it comes to estimating wildfire risk in terms of what people are doing, the climate, the vegetation, and I think that makes it difficult to communicate what could happen in the future, mainly because of these uncertainties. And so I think with that being said, I don't, want to get too political here, but I think it's important that we keep funding things that communicate to the public in a really clear way of what's been happening. And that's through kind of NOAA's climate.gov website, which has now been defunded, unfortunately, and also things like public media. I think, keeping those resources for people to go to, these trusted resources that people can go to and look at, what do we know about the climate? What do we know about certain events? I just think it's a really important thing to keep doing to kind of prevent these conspiracy theories from developing around both geoengineering and wildfires and extreme events in general.
So we're about to have our Q&A session. So if you've got a question, do get it in. But before we go to questions, I want to briefly ask, just leave this open to whoever wants to jump in. What are your views on the possibility of stratospheric aerosol injection potentially being integrated in climate policy? You can take that more broadly than wildfires. Does anyone want to jump in first? Brian, I see you unmuted yourself.
Oh.
Optimistically speaking. Yeah, I think there's a real need for considering SAI, but I don't mean in terms of promoting it or anything like that. I think much aligned with what you're doing and much aligned with what the SAI program is doing at Environmental Defense Fund. We're trying to just make sure that people aren't making these decisions without good data. Like, I think this is a very complicated and nuanced discussion about SAI. It's a global governance issue. It's a national governance issue. It's a policy issue. It's affecting a whole system. It's a systems issue. And so we don't want to be making decisions one way or the other in the absence of data. And so intentional and careful work on the impacts of SAI need to be done so that, 10 years from now or 15 years from now, if there is some catalyst for considering this more seriously, people aren't making those decisions in a vacuum. And so I'd say, yeah, there's potential benefits. There's a lot of concerns. There's a lot of broad implications about many different things, fires just being one bit. But if we're operating in just sort of a feels or a vibe zone where we don't have a lot of data to work from, we're in bad shape. And so there needs to be careful, sober, rigorous, transparent, peer-reviewed work on SAI, empirical work that we can ground those decisions in. And I'll stop there, but I could rant on that for a while.
Here. Anyone else?
I just want to mention, because Daniel mentioned about for the fire the uncertainty, and now Brian mentioned about how should we do the impact assessment. I've been working in this area for more than 10 years, and I do think we really, like, I see more and more people get involved in SRM research, but I do feel we need put more effort and more research to understand what's the impact. Even for fire, we are talking about, it's like probably only 3 or 4 peer-reviewed publications on how SRM going to impact wildfire. So it's just not enough. And when you look at fire model, there's a fire map. It's a big model intercomparison project, and all the fire models coupled with Earth system model, it's very hard for them just to represent the historic wildfire burn area. So there's a lot of research needs to be done. So that's my my big concern. We really need to have more research in this area.
And maybe just to give people a sense of scale here, I mean, there have been hundreds of studies now, maybe 1,000-odd studies into solar geoengineering. But, there's so many aspects of climate change, and it really is only a tiny fraction of the effort that's gone into assessing the familiar climate scenarios. But Danielle, I saw you wanted to jump in.
Yeah, I wanted to kind of go off on what Lili was saying and what you just said. Like, we do have, very few studies on understanding geoengineering impacts on wildfire, but we have many, many, many more studies and much more understanding of how greenhouse gas emissions and anthropogenic aerosol emissions can influence wildfire. And so I think for me, like, yes, SRM is important to study. We need to understand how it can help us, what the benefits are. But we know much better kind of the influence that mitigating greenhouse gas emissions and aerosol emissions could influence wildfires. And so I think for me, that's the first step towards trying to reduce the impacts of climate change on wildfire. And as Patrick has said a couple of times now, when it comes to wildfire, climate is just one piece of the puzzle, and there are maybe even much larger pieces of the puzzle that we as humans have more direct impact on.
Well, I'm going to ask Patrick if he has any thoughts, but you might have stolen his point. But Patrick, you're quite new to this topic of engagement with stratospheric aerosol injection in this topic. But what are your reactions to the idea and where it's going?
Yeah, I mean, I think what I said before is you know, to the extent that we're worried about things kind of scaling with global mean surface temperature, I think it makes sense. And you know, I don't think that the wildfires are a great example of that necessarily, but yeah, I mean, it can be, you know, thrown in as like one of the reasons, right? Probably nothing is no single impact is sufficient, but you know, it could be a small part of that bucket.
Great. Well, let's turn over to audience questions now. Have you got some set up, Mark?
Sure, we've got a few here. I've got one from Anu. I hope I'm pronouncing your name correctly. So the question is, what kind of role does forest logging and the loss of those carbon... Sorry, Kerry, you just took away the question. Could you put that? Hang on.
If you click on answered, you should be able to see the question.
Sorry, there we go. What kind of role does forest logging and the loss of those carbon sinks play in terms of maybe considering SAI more urgently, or does it have any other interaction with the way we think about geoengineering SAI? Perhaps I could start with Danielle on that one.
I'm just trying to read that too. What kind of role does forest logging in the loss of these carbon sinks? Yeah, so I think you know, that goes back to, you know, how do we kind of connect, like what we're doing is what we're continuing to do as humans by changing the land, by changing the climate, and kind of influencing these carbon sinks, and how SAI would kind of interact with that. And that's kind of back to, I think maybe Lili might have a better response, but she thinks more about you know, what the land is doing in terms of wildfire, and like what that looks like in terms of vegetation and the availability of vegetation. And I guess thinking about it more of a carbon sink way, it's, you know, carbon sinks are one way of mitigating greenhouse gas emissions. So, you know, if we have fewer carbon sinks, then that feedback might be higher. And so, yeah, it's a good question. I think it's kind of a complicated question. So if someone has a better understanding of how those two work together.
Yeah, I do
Maybe.
think that's a very it's like one important role in the whole climate system. So if you have like the logging and the loss of those carbon sink, then it will definitely make an impact to the climate system. And as I mentioned, even for global warming, for the Amazon rainforest, because of the deforestation and the rainforest have less sustainability to the drought. So it could result more like wildfire because it will be more sensitive to the humidity change. But when you put it under the scenario of SAI won't really change CO2 concentration directly. But if you consider other geoengineering research, then if you are if you are talking about carbon dioxide removal, then it's just against totally opposite of carbon dioxide removal. So yeah, I think that's a very complicated. It will affect a lot of parts of the climate system.
So there's a question here asked by Holly, and I might ask it, but also broaden it out. The question is, are any of today's presenters collaborating with Indigenous peoples regarding studying SRM, SAI? Perhaps, Lili, I might start with you. what is the role of working sort of with Indigenous people's perspectives in terms of studying SAI? But I might broaden that out to Brian and Patrick. To what extent is there work in terms of working with Indigenous peoples who obviously have a lot of experience of land management and so forth of their own with regards to tackling wildfire risk? But perhaps we start with Lili.
I mean, for my research, my research career, I haven't really worked with indigenous people yet. There has been only one workshop, really my early time when I was a PhD student, and they invited like some tribe to join the discussion, including climate change as well as potential geoengineering. So yeah, so my answer, I haven't really been involved with that kind of research a lot.
Perhaps to Brian or Patrick, to what
Sure.
extent can Indigenous people's perspectives be brought into thinking about wildfire management and risk?
Yeah, I can briefly say that we as the Environmental Defense Fund in our efforts have worked with several Indigenous communities or lots in both in the Western US and in Brazil, Ecuador, Bolivia, South America mostly. Fire is essentially a domesticated beast and has been for like 100,000 years. And so working with Indigenous communities with their experience with fire over that time period can tell us a lot. A lot of the efforts we're trying to do is basically restore sovereignty over the fire regime, the ability to burn. So there's efforts specifically in Northern California, Brazil, Ecuador to get people give communities the power to light fires when they think when they need to and when they want to, in conjunction with their historical traditions. I will say that this is a growing challenge because the climate is not the way it used to be. And so as we look forward, there is a need to include Indigenous knowledge because that's a huge reservoir of knowledge in how we manage climates in a climate change future. But we also need, traditional science too, because the future does not look like the past. And so there'll be imperfect lessons from the past. And so basically we need all hands on deck in terms of trying to understand what the future looks like. But a big part of that is the historical knowledge of the people in the place that they live.
And Danielle, I understand you have been working with an Indigenous community. Is that correct? Do you want to talk more about that?
Yeah, I've been working with a community in Northern California, and we've been mostly talking about wildfire risk in a changing climate. And Brian already pointed out all the important points that, this is part of their culture, their well-being, their resources for wildfire is really important for all of that. And I haven't actually talked to them about SRM, and I think that would be really interesting to hear their thoughts, since it can, influence climate regimes that do lead to more natural wildfires as well. And so I think that's a really good point from the audience, and I think that was Holly. And so I think it's a really good point. And Brian said all the important things already, so I didn't really have much to add. So thank you.
Thank you so much. I'm bearing in mind that it's 2 minutes till the end of the hour. So let's wrap this up officially. There are a couple more questions, though, we might add at the end once we've finished up. So just briefly, for those who have to leave at the hour, thank you so much for coming. We really appreciate your time. Pete, you can give thanks to the guests in a second. I would just like to add a quick appeal. If you could sign up to our newsletter, follow us and engage with us on social media, or if you'd like to reach out directly to collaborate us, work with us on these issues, we would be delighted. Pete.
Okay, well, yeah, thanks very much to our panelists, Dr. Brian Buma, Patrick Brown, Dr. Lili Xia, and Dr. Danielle Touma, and thanks for joining us. We'll be doing this again in around about a month.